Welcome to lesson 147 of algebraic concepts, or lesson 2147 overall. So the previous lesson I did was with like denominators. Now today we're going to combine with unlike denominators. So buckle up and be prepared to go on this ride. Okay, here's our objective. Here's our vocabulary. And you know what? For the last couple of videos, we really did not look at excluded values. I trust that you will go and look at the first 5 lessons in this series, starting at 2142, to understand what an excluded value is. But when I multiplied, I divided, and I added on the last couple of videos, I did not talk about excluded values. And I will not do that in this video either. So here's a picture. So take the time to pause through and read the objective, the vocabulary, rules and notes, and any pictures, because that's going to help you understand what we're doing in this lesson. Okay, so basically, when you have unlike denominators, you're going to have to multiply. So it's just like fractions. So if you have A over B plus C over D, what you're going to have to do is multiply the second fraction by the first fraction's bottom and the first fraction by the second fraction's bottom, top and bottom. Because we know when you multiply by the same thing, top and bottom is 1. So let's say when we add 2/3 and 5/7, you had to multiply this one by 3 over 3 and this one by 7 over 7. Because you can't just multiply the bottom by 7 and now they're 21. This becomes 14 over 21 and 15 over 21. These are called equivalent fractions. 14 over 21 reduces down to 2/3. Just like 15 over 21 reduces down to 5 over 7. You can't just go ahead and add the bottoms because they're different with fractions, because you change the value of the fraction. So go, and if you forget that, please go back and look at some of them early numbers and operations where I did fractions. And I did like 12 or 13 lessons dealing with fractions. So this is just a reminder, just to help you not look so bug out when I do the first couple of examples. All right, so now let us look at the first problem. We got 3k and 2k squared. They are not the same things. So what is the same bottom? So if I multiply this one by 3, I get 6k squared. And if I multiply this by 2k, I get 6k squared. Okay, so 6k squared is the same bottom. So that means I'm going to have to multiply this by 2k, top and bottom, and this one by 3, top and bottom. Okay, so now 7 times 2k is 14k, all over 6k squared, plus, distributed in 3, you get 15k plus 3 all over 6k squared. So now let's combine. 14k and 15k is 29k plus 3 all over 6k squared. And this is as simple as you can get. You can't do anything else, so we are done. Okay, so this one is easy. Let's see. All we have to do is multiply this one, top and bottom, by 4. And you get 3p over 4q minus, so I'm going to change this because that's minus 7p plus minus 7p. I'm going to just go ahead and leave it as minus 28p over 4q. And 3p minus 28 is minus 25p P over 4Q. And that's as simple as you can get that one. And finally, let's do something a little bit more difficult. Okay, x squared minus 4 is the difference of squares. So what do we have? Negative 4 over x plus 2 times x minus 2 plus 1 over x minus 2. Okay, what's missing from the second fraction? X plus 2. So if I multiply by sorry, my big old mitts got on there. So if I multiply by x plus 2 top and bottom, I get the same bottom. So I get negative 4 times x plus 2 all over x plus 2 x minus 2. That's not multiply. Why am I multiplying? It gets added. 4 plus x plus 2, which equals x minus 2 over x plus 2 x minus 2. Because I cannot distribute the 4 because there's a plus here. So x stays x, and negative 4 plus 2 goes to negative 2. And they cancel out, and I'm left with 1 over x plus 2 as an answer. And that is fully simplified. So those were our examples. Please try to practice problems on the upcoming page on a piece of paper, and I will see you at the end of the video for a recap. Okay, so this is plus, what's different here? They both have a G, so you just gotta multiply this one by 3 over 3. So all you gotta do. And 3G minus 3. And you know what? I'll leave this, I'm gonna leave it unsimplified. I'm gonna just leave it next to it. So let's leave it 3 times the quantity g minus 1 all over 6g plus g plus 3 all over 6g. And that didn't help me. Okay, so I'm going to now distribute the 3g. So I get 3g minus 3 plus g plus 3 all over 6g, which gives me 4g over 6g, which is 2/3. Look at that. The g's canceled out. Negative 3 plus 3 went to 0. And that's what I have left. Okay, problem 2. I'm sorry for the typo here. I know I fixed it on this. It's supposed to be y squared. And this is subtract. Okay, so factoring out a y. This is not a difference of squares because this term is not squared, but they both have a y. So take a y out, and you're left with y minus 3 minus 1 over 3 times y minus 3. So what do they have different? This one has a 3 that's different. This one has a y. So you're going to have to multiply this one by 3 over 3. And this one by y over y. Okay, so rewriting 3 over 3y times y minus 3 minus y over 3y times y minus 3 equals 3 minus y over 3y times y minus 3. We're going to factor out a negative 1 from here, which means we get negative 1 times 3 minus y. Sometimes I write faster than I think. Y minus 3 over 3y times y minus 3. And now you can see that the y minus 3's cancel out, and you're left with negative 1 over 3y. And that is your answer. And looking at the third problems, these just get added. 8 and 12. All right, so we need to find a common denominator from 8t squared and 12t cubed. This one needs a t. All right, 12 times 2 is 24. So you can multiply this by 2 and this one by 3t. Okay, so this one needs a 3t top and bottom to make 24 cubed. And this one just needs a 2 top and bottom. So what do we have? 33t over 24t cubed plus 2t over 24t cubed equals 35t over 24t cubed. All right, so what are the factors of 24? 1, 2, 3, 4, 6, 8, 12, 24. 35 is 1, 35, 7, and 5. So they have no common factors, but we can take out the t, and we're left with 35 over 24t squared. And that is as simple as you can get it. And that's all you can do. So that was our lesson on unlike denominators. You may get some more difficult ones than this. And I just did some easy ones to give you some practice. But like I told you in the welcome video, if you have a textbook, please try to do as many problems you can do on a section if you get stuck on something like this, because I know your math teachers might not give you problems this easy. So again, thanks for watching. Please bounce around to some other videos on various topics, and I hope to see you on the next video.